Bones and teeth are not the same. Bones are capable of regeneration. In some patients, when a bone develops serious problems, doctors can even remove the affected bone, place it into a pot, and boil it. After harmful cells are killed, the bone can be reimplanted into the body. Over time, newly grown healthy bone tissue gradually replaces the original segment. Once healing is complete, the overall strength is no different from before. Teeth, however, are a different story. If you bite into something hard and chip part of a tooth, it will never heal on its own. Even if the broken piece were boiled and put back in place, it would not reattach. It would still fall off. Since teeth cannot regenerate, does that mean they are dead? But inside teeth there are clearly nerves, blood vessels, and connective tissue. What purpose do these tissues serve? Are they there merely to make teeth more secure? What you may not know is that before you begin to lose your baby teeth at around 6 years old, the permanent teeth that will accompany you for most of your life have already formed. At that stage, there are actually 4 sets of teeth inside your mouth. This may sound surprising, but to understand whether teeth are truly alive, we must first understand how they form. When teeth are still developing beneath the gum tissue, the cells differentiate into 2 distinct types, responsible for forming dentin and enamel. One type is odontoblasts, and the other is ameloblasts. At this stage, both are living cells. Ameloblasts secrete minerals, while continuously moving upward, much like a 3D printer. Once enamel formation reaches ascertained stage, the ameloblasts die, leaving behind crystalline rods. Each rod has a diameter only about 1,000th that of a human hair. Millions of these crystalline rods together form the enamel layer, whose primary component is hydroxyapatite. This structure is extremely hard. Meanwhile, odontoblasts secrete minerals while moving downward, forming the dentin layer. Because of its unique structure, dentin contains numerous microscopic channels known as dentinal tubules. Dentinal tubules are critically important. They are filled with fluid. When you chew, food pressure changes in this fluid stimulate nerve endings, signaling to the brain that the object is hard and that biting force should be controlled. This is crucial because your molars can generate approximately 1,000 pounds of bite force per square inch. Without dentinal tubules, biting into hard objects would easily cause your own teeth to fracture. The key difference between enamel and dentin lies in what happens after the tooth emerges from the gums. Once exposed to air, enamel no longer has ameloblasts to produce new enamel. As a result, enamel damage cannot be repaired on its own. Odontoblasts, however, can still receive nutrients from the dental pulp. When dentin suffers minor damage, it can repair itself very, very slowly. This is why teeth contain blood vessels and nerves. They exist to supply nutrients to the dentin.